Good morning. Or actually, I guess it's almost afternoon. So, thank you for the intro. This is my first time addressing this industry this way, so I've been asked to talk a little bit about the future, the present, and what you believe. So what we're going to do really quickly is I'm going to introduce why I'm standing up here. We're going to talk a little bit about some trends. Then I am going to show you a quick case study about innovation. Then I'm going to make everyone in this room the world's foremost expert in machine learning and artificial intelligence. When you leave here, you will be the delight of everyone at every cocktail party you will ever attend, and you will be able to tell anybody everything there is to know about machine learning and artificial intelligence for about the next 14 days. And then everything I tell you is going to change, because the pace of this change is really spectacularly crazy. If you feel like tweeting, at Shelly Palmer is how you do that. I don't mind if you tweet. I don't even mind if you tweet negative stuff. We just like to be talked about. That's the world we live in. So the Palmer Group is a strategy, design, and engineering firm. We do strategic advisory for big brands, big business, big tech. We do the strategic side, does workshops and bespoke data summits and events. We do direct-to-consumer strategies and solutions and go-to-market strategies for our clients. And our engineering team is very involved in making minimum viable products. We do a lot of work in AI and ML and customer experience and user experience design is what we specialize in. And we spend an inordinate amount of time in the open source community. These are some of our tool sets. You won't know what any of these mean, but Formic is probably the most popular way you make forms in one of the most popular languages in the world. A few companies we're proud to have as users of our tool sets and our frameworks. We have been very lucky. Our engineering team is extraordinary, and we're very proud of them. But most importantly, we embrace the open source community for recruiting, for its value, and of course, if you want to be trusted, you must trust. And so there's a big lesson there. We also work with some trade shows, and we've been for a very long time, so I do have a little bit of a reason to be here. And let's just get started. The velocity of data is increasing and will always increase. There's no version of the world where tomorrow there's less data than there is today. The stat that I kind of like is that through the global data traffic centers, we're going to see about 165 zettabytes a year going through the internet. Does anybody in this room know what a zettabyte is? Well, it's a trillion gigabytes. Does that help in any way? So it's a billion terabytes, yes? Okay, so a terabyte is like what's the storage in the best computer you're likely to buy for around $1,500. And if you buy a cheap computer, it's probably half of that. So really what a zettabyte is 1,000 exabytes. And why do I care about exabytes? Because from the beginning of time to today, every word ever uttered by every human being on planet Earth doesn't make it to 5 exabytes. That's all the words ever spoken. As a matter of fact, up until 1986, the estimate is that the entire species of humans only created 227 exabytes in total up to 1986. There's a cliche phrase going around now saying that 90% of the data in the world was created in the last 2 years. We now create 1.86 exabytes per hour. The velocity of data is increasing and will always increase. But here's the important part. Information is not knowledge. The data means nothing. We are going to drown in data. What you must do is turn data into action, make it actionable. That requires some computational skill. So turning data into action is what we are about. A lot of people think Google's a search engine. They're not. They're an intention translation engine, and they are a purpose-built advertising revenue generator. They are absolutely dedicated to putting the right message in front of the right person at the right time to get them to make them the most amount of money. They happen to use search to draw you in because it's a nice value proposition for you, but they are not a search engine, which is why Google only hit a certain level of capability. Trust me when I tell you, Google could be a much better search engine, but that's not their business. They don't want to give you exactly what you want. They want to give you what you're most likely to click on that's going to make them money. That's how they're governed. Technology is used properly when it's used to drive your business goals. So you have a consumer value proposition, and the consumers have to be happy with it. You'll turn the data into action to answer that, but you have to have a business model that makes sense. So the three fundamental truths in our world right now is that the volume, velocity, and the variety of data is increasing and will always increase. Everything that can be connected will be connected, and most importantly, we live in the age of exponentiation. And what does that actually mean, the age of exponentiation? It means that today, you're experiencing the slowest rate of change you will ever experience for the rest of your life. It is just accelerating at an incredible rate. You believe that tomorrow is going to be exactly like today. You're going to get out of bed, do your exercises, have some breakfast, go off to work, kids go off to school, have some lunch, work the afternoon, blah, 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 rinse, lather, repeat. And then tomorrow you're going to basically do the same thing unless you have a vacation planned. That's completely wrong. It's completely wrong. Tomorrow is going to be nothing like today. Tomorrow there'll be 1.5 million new Android activations. There'll be 500,000 new iPhone activations. There'll be several billion phrases parsed by natural language understanding tools, and more billions of phrases being parsed by automatic speech recognition tools. The body of knowledge of mankind will hyper-incrementally increase tomorrow while you think it's the same day. So for the rest of this speech, I want you to think exponentially. And the way I like to do that, there are a lot of examples. Here's one. The lily pond has some lily pads in it. Each day, the lily pads double. So the first day there's 1 lily pad, the next day there's 2, the next day there's 4. This pond is now half covered. What day is this? 20-something, okay. 15, 25. It's day 29. Tomorrow, the pond is totally covered. We live in a world of exponentiation. Now, a normal human being would not look at this and think that tomorrow is the end of the pond. You think, oh, this is only half covered. There's plenty of time to go. So if I tell you something today and you say to me, it's not going to happen for 10 years. Folks, for most of the things we're talking about, they're either available to you right now or it's day 29. So let's move on. 3 giant megatrends are happening right now. On-demand, machine learning, and autonomy. On-demand, you know what that is. You press a button, you get a car. You press a button, you get some food. People want that. They love it. Rich people have always had on-demand. You're rich, you press a button, something happens. You're Gomez Adams, you pull the cord, and alert shows up and says you rang. Butlers, it's all been here for rich people. But now normal people get to press a button and they get whatever they want on demand. So now how do you compete? How do you compete in that on-demand world? Because the tier 1 tech organizations are only considering one thing: the lowest possible friction and the best possible customer experience or user experience. So when you make an app or you build an app, you're not competing with other trade shows. You're not competing with other apps in this industry or the industry that your trade show is in. You're competing with Facebook and Airbnb and Twitter and every other tier 1 tech site that has made a customer experience to reduce friction and draw the customers in. And when a person walks in to a store, a regular retail store, they almost always know if it's the right store for them to be in. If you shop at Brooks Brothers and you walk into an Urban Outfitters boutique by accident, you know none of the clothing is for you. When someone picks up your app and it looks like it's their father's app or they don't recognize it as modern, you're judged by how they experience you. And they are more and more and more and more and more experiencing you through their mobile devices, through the apps that you put out there. So this is autonomy and machine learning and on-demand all in one vehicle. This is an Uber self-driving car. And I have a giant problem with this picture. To me, all Ubers are already self-driving. You press a button, the car shows up, you get in the car, takes you where you want to go. I don't drive the car. It's a self-driving car. When I want to change the destination, I don't say to the driver, I need to change my destination. I type it into the app, and it shows up in the driver's GPS, and the driver just takes me where I want to go. So what's the difference between this self-driving car and the one that's going to be autonomous and work by itself? Well, the difference is really critical to everyone in this room. It's about $2 a mile to put a driver behind the wheel of this car. It's roughly 30 cents a mile to have it drive itself. Now, the bigger problem is that if you can do it for 30 cents, someone else is going to do it for 27, and someone else is going to be doing it for 24. It will be a race to the bottom to get the cheapest, safest ride. Uber just ordered 24,000 Volvos. They expect to put them on the road the end of 2020. So why is this going to matter to you? Imagine a world where we sell 20% to 30% less automobiles, but there's more traffic, because these cars are going to stay on the road all day long. And the cars you own now stay in the driveway or the parking lot most of the time. These cars are going to be on the road. Imagine a world where we sell 20 to 30% less cars. Imagine businesses when people can still get from place to place. What will the world look like? That world is going to start at 2020. It is more than day 29. So there's a couple different types of disruption, and the one that you should be worried about is demand-side disruption. Demand-side disruption comes from the consumers. They're the ones who tell you what they want. And very often it leads to the worst possible kind of disruption, which is supply-side. Because once you are disrupted on your supply side, your business is absolutely doomed. So here's the best example I can think of quickly that you would all know, and that was when BlackBerry was in its heyday 10 years ago. Everyone in this room carried a BlackBerry, and you loved it. And you might have had two, one personal and one for business. iPhone launched about 10 years ago. And the people at Research in Motion, now BlackBerry, didn't think very much of it, didn't care about it, and it didn't get a lot of traction when it started. It was for those Apple people. By the time BlackBerry figured out that the iPhone was real, it was over for them. BlackBerry didn't know how to make glass screens. They didn't know how to do the computer programming. They had no concept of an app. BlackBerry had an LED screen and a keyboard. They had no way to source. Their supply chain was completely caught off guard. They could do nothing. No matter what amount of money they spent, they could do nothing to stave off what was about to happen to them. So let's talk about the kinds of innovation you need to prevent this from happening to you. First of all, there's routine innovation, which means that you just have to get better every day. Continuous improvement. It's table stakes. Everyone's going to do it. Your competitors are going to do it. You have to do it. We won't talk much about it. Disruptive innovation is interesting because it takes existing technology and it applies a new business model, and this can be pretty disruptive. If you think about radical innovation, this now starts to get into the place where you have no defense. Let me give you a good example of radical innovation. If I'm a beauty company and I make potions and color and treatment and perfume, and I routinely send explorers and chemists down to the Amazon rainforests to find unique flowers and interesting plants that they can make things out of, and this has been my business for 100 years. And tomorrow, somebody in Silicon Valley comes up with a gene sequencing tool set, and they molecularly engineer the new treatments and new colors. You're done. They're going to kill you, and there's nothing you can do about it because you're not going to have the science or the technology to compete. What you could do is buy them, but that's about it. Or buy a company just like them. But you're not going to transform go down and pick plants out of the rainforest business into a molecular engineering firm. Not overnight, anyway. And then, of course, architectural disruption, which is the one everyone should fear because that's new technology and a new business model. You would argue that Spotify or any of the over-the-top streaming services are new technologies and new business models. There's a very high-quality way to stream video, and now it's access being as valuable as ownership. I don't need to download. I don't need to own it. All I need to do is have access to it. So access is as valuable as ownership completely turns the model on its head. I never need to own it. I just need access to it. Moving on. So you need to create an innovation strategy for your organization. And it's not a project the way we understand projects, which is that, hey, I've got a new project and it's got a beginning and a middle and an end. No, that's not what an innovation strategy is. Innovation is a commitment to lifelong learning for your entire leadership team and all of your staff. And every day you are going to think about new ways to do what you're doing, and you are going to be rigorously, absolutely, doggedly committed to return on investment. Because it is super easy to invest against everything and say, oh, we'll try this, try this, try this, try this. That kind of experimentation is great if you're a monstrously large company and you have a pure research department, that's great. But if you're a normal business and EBITDA is what you are governed by, if you've got a private equity partner or if you've got shareholders, you have to be sure that you are placing good bets against probable futures, things that you think have a reasonable chance of changing the way you do business. So I have a quick little case study here. We were very, very honored to be asked by the National Kitchen and Bath Association to review their internal technology stack about 3.5, 4 years ago. And it was, like so many of the clients we have, it was put together with love and care over about 15 years by about 20 different IT professionals. It was a Frankenmonster, a horrible tech stack with a million legacy things all plugged together. And I didn't really want to mess with it at all. And we thanked them very much for the opportunity to look at it and said, look, love you guys. We'll see you next time. So, but what you could really what you could use is a little strategy about what to do going forward with your tech stack, because I don't want to build a tech stack for you unless I know why. So we did mission, vision, values, content pillars, brand personality. We built a brand playbook and a go-to-market strategy, and we did that by asking a bunch of questions. Now, if you ask the wrong questions, you're guaranteed to get the wrong answers. But if you ask the right questions, you can get the right answers. So some of the questions we asked included, what does it mean to be a trade association in the 21st century? Not how do you be one? What does it mean to be one? Don't tell me how. Don't tell me about the techniques I'm going to use. What does it mean? And could you reposition this particular association, or any for that matter, to become the center of their members' or constituents' digital lives? Because we live in a world that is exceedingly digital and going to be digital every day. So how could I become the center of their digital lives? And then, is it possible that that association could compete with, in the NKBA's case, the commercial organizations and startups that were taking an amazing amount of money out of the system? For the National Kitchen Bath Association, Pinterest was taking a ton of money away from them, as was House, which had this fantastic place where you could buy kitchen and bath stuff, and all of the members of the NKBA were spending a ton of advertising and marketing money on House. Why wasn't the association helping them with that? So what we ended up doing is building them a digital platform from the ground up, absolutely soup to nuts. And we started with a database of their members, and the members were given profiles very much like LinkedIn or Facebook, kind of combined with a little Pinterest thrown in there. We put in super high quality video and pictures. We put in lead generation. We put in organic SEO that they had never had before. It was a whole bunch of benefits. So all of a sudden, what we did was we took an organization where they had a trade show, and if you were a member, you got a discount to the trade show, and you got a paper magazine 6 times a year, and if you were an exhibitor, you got a discount to the trade show. And we literally put them smack in the center of the digital lives of all of the businesses that are involved in the association. This value creation, this specific value creation, changed the relationship of the organization to its members. Now, everybody in this room knows, it is way, way, way easier to keep a customer than it is to get a customer. So how do you absolutely change the game? Well, digital doesn't need to just be for lead generation to sell tickets. Digital can be for customer retention to add value to their lives. And so now we have the NKBA members literally transacting through the site. And it's not an e-commerce site, but it has components that allow them to do this. They can drive growth. They can drive growth for every business that interacts with them. And they do that because they've made their members vicious digital competitors in a world where they could never have the technology or the money to do it themselves. Small little 1 and 2, 3 person companies, even 50 person companies, do not have the kind of resources to invest against the future. All right, if you want to play with that, it's at nkba.org, and you're certainly welcome to go there, and you can call up their leadership team and ask them about it. We've really enjoyed working with them. We're still working with them. We've got another 2 years to go on the project. 3 buzzwords that you've heard a lot about. 3 great buzzwords: AI, blockchain, and AR. Now, artificial intelligence, I promised you, machine learning, I will make you the world's foremost expert. Blockchain and augmented reality. Let's quickly go through blockchain. Who in this room can explain blockchain to me? Okay, 2 of you. That is fantastic. You guys want to come up here and we'll just... Okay, I'm going to take you through blockchain really quickly. Blockchain is actually the underlying technology in Bitcoin. And it should be referred to as a distributed ledger because of the nature of what it is. Blockchain is a kind of a brand name for a specific approach. Think of a blockchain or a distributed ledger as a block of granite. What does a block of granite do for you? Well, when you carve something in stone, it's pretty much there forever. For the last 2,000, 3,000 years, some of the carvings in Egypt have been there unchanged. If you carve something in stone and someone changes it, you can easily tell that it has been changed. And most importantly, the block of granite doesn't care at all what you write on it. That is a blockchain, metaphorically. So what do you use blockchains for? Well, you use them for transactions, to record transactions. And the transactions are done almost always in the form of a smart contract, which is just like a regular contract, except that there are digital conditions to be met. So, a smart contract is almost identical to a vending machine. You walk up to the vending machine, you decide you want something, you put in your money. If you put in the right amount of money and the conditions are met, it'll give you your item, and if not, it asks you for more money. That's a smart contract. When you have completed that transaction or not, you walk over to the blockchain and you hammer it in stone, and then you come back over and you do the whole thing over again. So that is blockchain in its most metaphoric way. That's as good of an explanation as anyone in this room needs, but I will tell you that every one of you is going to end up being pitched something with blockchain for your trade show this year. In fact, you'll be pitched by dozens of people telling you how important blockchain is, and IBM's going to tell you how important it is. Everybody's going to tell you how important it is. I'm going to give you the one question you need to ask that will make this all make sense to you and will stop everyone in their tracks who's trying to hustle you. You say, and I quote, oh, first of all, you should listen to the presentation very politely because they've worked hard on it. Then you say, hey, that's a really interesting idea. Tell me, why is blockchain the appropriate technology as opposed to just a well-structured, very secure database? Then drop the mic and wait for them to answer. If they don't have an answer as to why this shouldn't be done with a database, it's not a blockchain project. There are very few use cases other than cryptocurrency where a blockchain is the best way to do something. I'm not saying they don't exist. They do. We have many projects in play right now that use blockchain. But in practice, a lot of people are just using it as a buzzword, and it is a giant waste of your time. What's cool about it, and you can go deep on YouTube or Google, smart contracts can be used for all kinds of stuff. You can use them for real estate, auditing. You can, if you've got some kind of proof of concept thing you're doing, or if an affidavit's a performance, you're trying to do accounts receivable, accounts payable, auditing. There's a lot of good ways to use blockchain. But in almost every case, the only reason is that there are parties that don't trust each other that need to transact. All right, moving on. This is an iPhone. That's an iPhone 10, actually. Now they're up to the 10X, the S Max, and 10 regular 10, I guess. But the most important part is that it has a stereoscopic camera. So does the Samsung Galaxy S9. What does a stereoscopic camera do? Well, it allows you to understand the space that you're in. So you can now measure things. The phone knows, because just like you have 2 eyes and you can understand the three-dimensional world, a stereoscopic lens can understand the physical world. So here's the best example of augmented reality for gaming that I've ever seen. I've wanted to play with a lightsaber since 1977, and I got a chance to do it, courtesy of Disney and Lenovo. Really a spectacular experience. If this doesn't sell AR gaming isn't going to sell. Disney has so many great franchises. It can tell so many great stories. The Star Wars story is just only one of them. There's me fighting with a lightsaber for the first time when it came out. I was pretty excited. You can see the lightsaber fully extended in my visor. It had haptic feedback. It made the sound. It felt like you were actually doing it. It's unbelievable. Unbelievable. This is Microsoft's vision of augmented reality, and I don't know if it's real or fake, but HoloLens from Microsoft is about the best version of this that is out there today with eyewear. the real estate that they're using for football, the kinds of stuff they're doing shouldn't matter to you, and don't pay too much attention to what they're showing you. What they're showing you is your imagination. If you can imagine it, it can be done. But I want you to understand as you look at this how much data is going in both directions. I've got data coming from the user because the user wants certain things and is expecting certain things from their experience. And I'm using a ton of data from the player database. I might have a cognitive agent looking at the game, giving me play-by-play in color so that the system understands the game it's watching. There's a lot of data moving back and forth. And what this should tell you is that AR is not only happening, it is just limited by your imagination. Before we get to machine learning and AI, I want to say that how many people in this room have the Amazon app in their phone right now? Amazon shopping app? Just a few of you. Well, if you do, there's a thing called AR View. You go to the upper right-hand side of the app, and there's a camera button. Hit that camera button, and you can hold your phone up and start placing items you can buy from Amazon in your real world. Now, that's a parlor trick. It's not a paradigm shift, but so many companies, fashion companies, makeup companies, everybody is using some version of augmented reality. Now, Nicole got up here and was talking to you a little bit about augmented reality and what could happen in a trade show environment. I don't know the trade show attendees are literally going to walk through the trade show with a headset on, but they may walk through with regular eyeglasses or having their cataracts changed with heads-up displays or implants in their retinas or cuffs that attach externally to the central nervous system that allow you to see heads-up various data points. We're on the cusp of 5G, the fifth generation wireless network. As that deploys over the next 3 to 5 years, you're going to have throughput speeds like we've never seen, and more importantly, we're going to have very low latency in 5G. And what does that mean? It means that we get a very cheap sensors in and around us in our self-driving cars, on our person, and we can quickly get the information up to the cloud. The cloud computing can happen, whether it's AI or straight computing, and it can come back down all in under a few milliseconds. Right now, we're in a 50 millisecond delay with 4G and far greater with 3G. But when you start talking 1 and 2 milliseconds, now we're inside the human experience of instantaneous. So we're on the cusp. It's like day 29 in 5G and AR. Right now, everybody's walking around with their phones. And look, it's bad enough when we walk around like this and walk into walls, right? We're always texting and typing. I don't think the world is really going to be people walking around like this because it doesn't make sense. Something is next, and handsets are not forever. So pay attention to augmented reality. This is one of the few places where you should experiment in every way you possibly can with any company that is coming to you with an idea, because you will not know where the great, new, unbelievable augmented reality experience is coming from, and you will not know how to use it in your business. You can be a fast follower, but if you are going to be a fast follower, understand how much of an advantage the first movers are going to have in augmented reality. All right, I promise to make you all the world's foremost experts in machine learning and artificial intelligence. We're going to go quick, but it's pretty simple. This is Arthur Samuel. In the late 50s, he invented what we now know as computer checkers, the first computer game. Very importantly, in Arthur Samuel's world, the verb to learn did not mean to learn. It meant to compute. That was simply trying to compute the best next move and score it. A little while later, Garry Kasparov faces off IBM's Deep Blue. Deep Blue is a cool technology. It's not artificial intelligence. In a chess match, a chess master may have the ability to see into the future about 25 moves that are possible, and there aren't more than 30 moves that are possible in a chessboard at any given time. Kasparov was the best player in the world. Deep Blue was a really, really, really good computational tool set, and it beat him, and he was sad about it, if you remember. Very sad. There's a great video on YouTube about him talking about his experience. You should see it. Now, Watson was mentioned by the previous speaker. Watson humbly is evolved, and it's There's a lot of marketing hype around Watson, but when it came out, they had it play Jeopardy. And this wasn't an artificially intelligent system. This was a system that was particularly good at a very narrow, very purpose-built technology called question answering technology, cleverly. They fed the body of knowledge of each of these subjects into Watson, and they also had a very good natural language understanding and speech recognition or text recognition parser, and Watson could look at the question, understand the question, which is no small feat when this happened, and then go get the right answer. And it won Jeopardy pretty handily, as you can see, by quite a few dollars. So there are a couple different types of machine learning. The first one is supervised learning, where you teach the machine to do what you want it to do. If I gave each one of you a 10 by 10 matrix about your business, 10 rows, 10 columns, all about your business, within a very few minutes, you would be able to tell me everything I need to know about this matrix. You'd say that's double income, no kids, this is new family, whatever it is, you'd know what they were. But if that spreadsheet was 25,000 columns by 250,000 rows, you're a human being. There's nothing you can do to look at that data. So what you do is you call your data scientist in and you say, hey, I understand how to find this pattern. Let me explain to you how I understood this spreadsheet. And they reduce that to mathematics and ultimately computer code. And you teach a training set to go look for that pattern. Now, it's not as simple as that because there are serious complexities in taking something that's so tightly fit to a small data set and expanding it to a large data set. The problem is called overfitting, and it's why data scientists cost $500,000 a year each, because it's more art than science. There's a lot of creativity in data science. But at the end of the day, you are teaching the machine to go look for a pattern. So of course, the next possibility is unsupervised learning. You have this monstrous data set. I know for a fact that your industry is sitting on a ton of data. So you say to the computer, I know there are patterns in here, I just don't know what they are. Surface the patterns and let me have a look at them so I can apply my knowledge, my domain expertise to these patterns. So that's unsupervised learning. There's another type of artificial intelligence or machine learning, and it's called reinforcement learning. It's also known as hierarchical learning or deep learning or neural networks is another name they use for it. Deep learning has to do with the way that the computer deals with data in layers. Neural networks are much smaller programs than algorithmic machine learning or statistical machine learning programs. A machine learning program might be 15,000, 20,000 lines of code. A deep learning program might be 500 to 700 lines of code. They're just different approaches. The way that a deep learning system looks at data is the way a newborn baby looks at like a rattle. It picks the rattle up, it bangs it on its head, it bangs it on the floor, tries to eat it, it throws it across the room, it listens for the noise. That's what a computer does mathematically when it is in a neural network. It is really important that you understand what this means. So let me take you through what this means. Who recognizes this game? This is Go. It is a 2,500-year-old Chinese game played on a 19 by 19 grid with black stones and white stones. It's very similar to capture the flag and chess and Chinese checkers all rolled into one. Here's the important part about this game. Where a chess master might have 25 or 30 possible moves that they could do next, a Go player has 10 to the 160th possible next moves. Now, how big is that number? There are only 10 to the 80th atoms in the observable universe. So this is an exponentially larger number than that, and no computer in our science could compute Arthur Samuels to compute the way he did his checker game. You got to have a whole other system to figure out how to play Go, so this should never have happened. Well, a couple of years back, Lisa Dole, the 9th Dan Devine Go player in the world, was challenged by AlphaGo, owned then and now by DeepMind, which is now owned by Google, to play a match of Go. And he lost 4 games to 1. The one game he won, he exploited a thing that he saw, and the computer figured out what he was doing and killed him on the next day. I have an article at shellypalmer.com called AlphaGo versus You, Not a Fair Fight. Move 37 in game 2 changed my life. It's the first time I ever saw a computer think. It put a stone in the middle of nowhere. Even the commentators couldn't believe it. And I was thinking, yeah, humans are going to win. Computers can't do this. This is way too tough. Way too tough. The next 10 moves, I watched this computer head fake this guy and then kill him. Never seen anything like it. And importantly, in real Go, the game that humans play, you like to win by a point. There's some honor in winning by a point. But you can win by a half a point. Computer doesn't care, it just wants to win, has no emotion. Won by half a point, destroyed him. This guy is the best in the world, not the ninth Dan Devine Go player. This guy is the best Go player. He played AlphaGo a little while after that. It won him 3 games to nothing, and when he was interviewed, he said it was like playing a Go god. 6 months later, AlphaGo Zero shows up. It's trained by AlphaGo. It gets really good really fast. And then I know you were told yesterday about AlphaZero. AlphaZero is a fascinating cognitive agent. It is a fascinating environment because it is known as a tabula rasa ML environment, machine learning environment. What that means is it's blank. It's just ready to learn. They didn't teach it the game of Go. They told it the rules. One more time. They didn't teach it to play Go by showing it lots of Go games. They taught it the rules, period. Then it played itself. In 2 hours, it learned to beat everything that had ever played chess or Soji on planet Earth. And in 4 hours, it beat everything that had ever been built to play Go on planet Earth. 4 hours of training. Very importantly, Go is a perfect knowledge or perfect information game. What does that mean? I see the entire board from the very beginning of the game. I know where every piece is. I know what my opponent's doing. I know what I'm doing. I may not win, but I have perfect knowledge of what I'm looking at. Perfect knowledge of what I'm looking at. That's important, and I'll tell you why in a second. Because life isn't like that. So this is just about 8 weeks old now. This is also from our friends at DeepMind, owned by Google. This is Capture the Flag, played by 2 different teams, except the teams are made up of 2 different cognitive agents each. So these are 4 different AIs, 4 completely separate AI systems. 2 that were made in red, 2 that were made in blue. And it didn't take them very long for the red ones to figure out that they should team up and cooperate, and the blue ones figured out they should team up and cooperate. And so this is completely untrained. They learn to cooperate and play each other as teams. AI cooperating by itself. Kind of a fascinating evolution in artificial intelligence. Who knows this game? This is Texas Hold'em. It's a poker game. This is a very special kind. It's heads-up poker. So the way the game works is you get 2 cards dealt down. There's a round of betting. 3 cards are dealt up, round of betting, next card up, round of betting, next card up, round of betting. You can go all in, meaning you can put your whole stack in at any time to try and end the game and win. So you cannot play Texas Hold'em by the numbers. Because unlike Go, where there's 10 to the 160th possible moves that your opponent could have, there's only 169 combinations of cards your opponent can have in poker. If you play by the numbers like you play blackjack, you're going to lose. You have to play the person. Because it's a recursive, iterative game. I know that you know that I know that you know. Like negotiating, right? I think she has a flush. She thinks I have a better hand than that. I think she thinks I have a better hand than that. I'm going to bet this way. That's life, negotiating back and forth. Computers shouldn't be able to do recursive, iterative games like that. Well, Lebratus at Carnegie Mellon solved that. It took the 4 best Texas Hold'em players it could find, played 220,000 hands of poker against them, and beat them by $2 million. That was the same time that AlphaGo was coming to prominence. So now you've got computers that can bluff, cheat, gut into it, lie. Sound like salespeople. It's unbelievable. Anyway, at the end of the day, these are purpose-built systems. Purpose-built systems. This is AI, augmented or artificial intelligence. It is not AGI, artificial general intelligence. These machines will not take over the world. They do not eat people. It's not Skynet. They're purpose-built. This one plays Go. This one does MarTech, marketing technology optimization. This one does supply chain optimization. That's what they're built for. This one recognizes faces. This one recognizes speech. Obviously, speech recognition is huge. Just as quickly as we can, Alexa is the most popular version of this. Google has a fabulous version as well. There's 2 component systems working here. One is automatic speech recognition, which is now in the 96th, 97th percentile of accuracy. I do not think my wife understands 96% of what I say, so it's better than me and my wife communicating. But I will say to you that understanding the word, what's spoken, is not not natural language understanding, the other system. The other system tries to interpret what you mean. You saw Betty, the chatbot, being able to look at one-word answers really quickly. If it's interacted with one or two words that it really understands, it's good. But if you said to Betty or any AI system, any natural language understanding system, Shelly drove down the street in his car, a 3-year-old human being knows that cars go on streets. Computers don't. Computers have no context. So it's called prepositional phrase attachment ambiguity. Shelly drove down the street in his car. Is it Shelly drove down the street in his car, or is it Shelly drove down the street in his car? Which? You can't tell. You have to know. It's context, and the computer has none. This happens in every language across the board every day. And you don't write conditional phrases. You train AI systems. This is not a slam dunk. But that said, these computers learn every day. It's their job. This is Google Translate. It's the largest AI project on planet Earth. It was a statistical machine learning project for several years. Now it is a neural network. When it became a neural network a few years ago, a year and a half ago, basically, it increased exponentially in its capabilities. You'll see that it's using augmented reality to try and match the fonts, and it's also understanding what it's seeing, and it's in your phone right now. If you have an Android phone, it's built in. If you have a Samsung phone, it's under the Bixby button. If you have an Apple phone, download the Google Translate app, pick the language you want, and you hold up your phone to a Chinese menu, and you'll see it in English. Google also has Pixel Buds, and for an industry like this, that's kind of fun. You say to Pixel Buds, "Okay, Google, help me speak Spanish." Someone speaks to you in Spanish, you hear it in your language. And it goes the other way, too. So it's nascent technology. I'm not a big fan of Pixel Buds 2, the earbuds, but guess what? That's iteration 1. Wait till these guys get this right. How would universal translation change the trade show industry if you could walk and everyone could talk to everybody? How would that change your business? It's day 29. So, how do you see the future? What do you believe? These are really important questions. And based on your belief system, what will you do tomorrow that you would not have done today because you believe it? So, these are some theses for 2019 that my company uses. We have hundreds of them, and our leadership team gets together about every 2 weeks, 3 weeks, and we start asking questions. Data is more powerful in the presence of other data. Do you believe that? Is a profile really better than just a piece of data? The answer is yes. Okay, if you believe that, what are you going to do about that? Earlier I said access is as valuable as ownership. People don't want to own anything anymore. They just need access to it. Do I believe that? Then how am I investing? How am I changing my business? Anything that can be hacked will be hacked. Absolutely true. What am I going to do about it? What do I have to protect? What does it matter? What is the information I can allow to be hacked, and what is the information I cannot allow to be hacked? These are theses that are general that we use for examples. We have some that are specific to our business. Take your teams, sit with your senior leaders, and ask them about the future. What do you believe? How do you see it? And then, as a group, what are we going to do to make that belief system actionable? This is the stuff that has my attention, and it's really important that we talk about the first bullet point. And this has nothing to do with your business. This has to do with you. Machines are not going to take over the world, and machines are not going to take anybody's job. But people are going to lose their jobs, and they're going to lose them in droves. And here's how it's going to happen. Raise your hand if you know what Photoshop is. Okay, great. It's an art program. There are many programs that you do pre-press and artwork in. Right now, an art director is given an assignment, make me an ad, and he or she does a great job because they're a great art director and they do the ad. They're also handed a page of deliverables with about 500 versions that they need for the internet, for print, for everything, for TV graphics. And a group of less paid, lower quality art directors take the work and they make each file. It takes a couple, 3 days. The senior art director looks at it, makes some adjustments, and it gets delivered. In an AI environment, the senior art director gets the same assignment, and she presses a button when she's done designing the ad, and it's approved by you, the senior management, and the computer does all the iterations in about 3 seconds, and then she just makes a few adjustments and ships it in under an hour. 3 days of work for a team of 30 reduced to under an hour. Those 30 people no longer have a job. There's no longer a farm club. They can't work with the senior art director and learn about how to be a senior art director. Everything we know about that kind of labor is about to change. If it can be automated, it will be automated because your competitors will have to automate it because EBITDA is God. God is EBITDA. And if you want more money, you can either increase your productivity or by reducing your costs or increasing revenue. So human-machine partnerships are critical. That art director is a human-machine partner. That's how it works. I'm doing the things that humans do over here because I'm human and I understand human stuff like creativity. And then I've got plumbing I got to do. I've got to crunch numbers. I have to turn data into action. And when you put those two things together, your domain expertise, and the computer's skills, you have a new species, an augmented human. So if you don't think of it as artificial intelligence, I'd be happy. I'd like you to think of it as augmented intelligence, specifically on augmenting your best people, and then train your people to be the best at that. Are you the best man-machine partner you can be, human-machine partner you can be? Because that person's going to have competitive advantage that no one else in the organization or your competitors' organizations will have. Now, I've spent a lot of time talking about algorithms and complexities and interesting things where humans control the world. But I have to tell you, that is an arrogant position that I do not recommend us to keep. This was invented by Claude Shannon. He worked at Bell Labs in the 50s. Tremendously gifted guy. And this machine has one algorithm and one algorithm only. I'd like to show it to you. It has been programmed with one instruction: turn yourself off. But you're a human and you want it to be on. So you say, I want you to be on. And it says, no, thank you. And it turns itself off. No, but I'm the human. I control you. I'm turning it on. Yeah, but it's turning itself off. Be on. I'm your boss. I'm programmed to turn myself off. Maddening, right? What does this tell you? This is one algorithm. What it tells me is that we have to be a little careful. We have to be a little careful about our arrogance in playing with this technology. We have to be humble and we have to be thoughtful because an algorithm does not need to be very complex. It will really piss you off. Thank you all very much.